Welcome to some puzzling with geometry and Legos. In this puzzle, Lego Catwoman has a triangular shaped garden that is completely fenced in so as to keep her vegetables and things safe from her monkey friend. But Lego Catwoman has a question. If she removes the fence and reconfigures it into a circular shape, how will that affect the area that is enclosed by the fence? Let's see what we know for the triangle so far. We know that we have a right triangle because there's a little square in the corner down there to indicate that it's a right triangle. We also would be able to figure out the perimeter of the triangle by adding up all of the edge lengths. This triangle has a perimeter of 12 meters, and we can figure out the area of the triangle by using the formula for the area of a triangle being 1/2 base times height. The area of this triangle is 6 square meters. So we know a lot of things about this current triangle, but we need to try to translate this over to a circle. And in particular, we wanted to know about the area of the circle that would result. So let's take the edges of this triangle and reformat them into a circular shape. I've taken the edges of the triangle and I've started to bend them so that I can make a circular shape. This is the 5-meter edge that was part of our garden before. This is the 4-meter edge. And then this is the 3-meter edge. And I think you would agree that mine is not quite circular, but I also think that you will get the idea of how this works. In this circle, we need to talk about the area, the space on the interior of the circle. And in order for us to do that, we need to use the formula that the area of a circle is equal to pi times the square of the radius. The radius of any circle is the measurement from the center of the circle out to one edge. There's the radius. And right now I don't know that radius. Potentially I could take some kind of tape measure and come along and measure it, but that's not terribly accurate, especially when my circle is a bit squished like this one is. So how to get around this? Well, if we think about the things that we do know from back there at Lego Catwoman and her monkey, we knew that the perimeter of the triangle was 12 meters. And the perimeter of this circle has to also be 12 meters because we use the same amount of fencing all the way around. So we know that the perimeter of the circle must be 12 meters. And in a circle, the perimeter has a fancy name. It's called the circumference. And we know a formula for the circumference of a circle as well. We know that the circumference is equal to 2 times pi times whatever that radius is. So if we want to find the radius exactly in this case, we can use this formula with the circumference that we know. We can solve for r, and then we can translate over here to the area formula to complete the solution process. So if we do this, the circle has to be the total fence length all the way around the garden, and so that needs to be 12, will be set equal to 2 times pi times r. With a little bit of algebra, we can solve this equation for the radius. We'll divide both sides of the equation by 2 pi, so that the radius is equal to 12 divided by 2 pi. And you can leave your expression for the radius like this, or you can do a little bit of simplification, but I would recommend that you leave it in its exact format. Either this version or the other version would be 6 over pi is equal to r. That way you don't have any rounding right here. We're going to take this value for the radius, and we're going to go substitute it into the formula for the area of the circle. So the area will be equal to pi times the quantity that we just found for the radius, 6 divided by pi, and that gets squared. And now would be a good time to go get a decimal value for this. So grabbing a calculator, we need to do pi times parentheses, 6 divided by pi, and that quantity needs to be squared. When I ask the calculator for a result, I get a value of about 11.46 when I round it to the nearest hundredth. 11.46, and that's an area value, so this will be measured in square meters for a unit. In the beginning of this video, we had a question: if the fence is removed and reconfigured in a circular shape, how does that affect the area? Well, I think we have an idea about that now. The area of the triangle in the beginning of the video was 6 square meters. And here in the end, when we find the area of the circle, we get 11.46 square meters. And so the area nearly doubles when we switch from a right triangle for the garden to a circle using the same amount of fencing. And you might be wondering if this is reasonable. We got quite a bit more space to it. If you do a little bit of research, I think you'll find that a circle is a very optimal shape to use if you're trying to get maximum space in the interior of a figure and you have a fixed amount of perimeter to go around the outside.